Bam, it's true. In this video, we're going to move on from the product rule and work out a few examples of the quotient rule. The quotient of f and g, or f over g, of two differentiable functions, f and g, is itself differentiable at all values of x, for which g of x is not equal to 0. The formula, or the rule, is the derivative with respect to x of f of g over, f of x over g of x is equal to g of x times the derivative of f of x, or in other words, the denominator times the derivative of the numerator, minus the derivative of the denominator times the numerator over the denominator squared. So we're going to take the denominator, put it first, take the derivative of the numerator first, minus, and then the derivative of the denominator times the numerator. And it's very important that you get this order correctly, because in the middle here we have subtraction, and subtraction is not commutative. So if you happen to get this backwards, where you take the derivative of the denominator first and then the numerator, you are going to get the wrong answer. Where, of course, g of x, the function, we cannot get an answer that's equal to 0 from the function, because then we're divided by 0, and that is undefined. So these examples are going to take up a little bit of room, so I need to erase this. I'll leave this up here so we can reference it as we go through the work, but I need more room than the bottom of this chalkboard to do these examples. So, be right back. We have y equals 3x minus 1 divided by x squared plus 2. Y prime, or the derivative of y, is going to be equal to the denominator, x squared plus 2, times the derivative with respect to x of the numerator, which is 3x minus 1, minus, now we're going to take the derivative of the denominator, g prime, so that'll be x squared plus 2 times the numerator, all over the denominator squared. Don't worry about multiplying that out. Leaving it, the binomial squared, is perfectly fine. We have x squared plus 2. The derivative of 3x minus 1 is equal to 3 minus the derivative of x squared plus 2. Get power rule, right? Use the power rule here as well. We have 2x times, and the derivative of a constant is 0, so just 2x, times 3x minus 1. All over that binomial squared. All we have to do now is clean up a little bit. Don't have to FOIL this out, like I said, or distribute that out. But we have 3 times x squared and 3 times 2. We have, and I'm going to do this whole negative 2x and distribute that through the parentheses. We get 3x squared plus 6. And negative 2x times positive 3x is negative 6x. Negative times negative is positive, so plus 2x. Oh, excuse me, x times x is x squared. All over x squared plus 2 squared. We have some like terms, so we have 3 minus 6 is, of course, negative 3, so negative 3x squared plus 2x plus 6 all over x squared plus 2 squared. And I always check my work even though I made up these problems, so just make sure negative 3x plus 2x plus 6 over x squared plus 2 squared. Great! Next example. Woo! Next example. F of x is equal to 2x plus 1 over the square root of x. Okay, again, like to get those radicals out there, write that in with a fractional exponent. Secondly, I discussed this with the power rule as well. These are long and tedious. I mean, you have to use the power and the quotient rule if you need to, but if you can adjust the equation a little bit, the function you're given, to allow you to use the basic differentiation rules, you will save yourself a lot of work. So, and I'd be doing the same thing if this were just a simple constant of like 5. as well as the square root of x, because it's a single term, and it'll cancel nicely with the two terms on the numerator if I pull that fraction apart. When we add or subtract fractions, when we have a common denominator, we just copy that denominator. So we're going to be able to pull this apart to be two separate fractions. So we're going to write this as 2x plus 1 over x to the 1/2 power. Then we're going to pull those two terms apart in the numerator and write two separate fractions with the common denominator of x to the 1/2 power. And that's going to be equal to 2x over x to the 1/2 power plus 1 over x to the 1/2 power. And, well, here we're dividing by like bases, and when you divide by like bases, you subtract the exponents, and 1 minus 1/2 is 1/2, so this is equal to 2x to the 1/2 power. And though I'm teaching the quotient rule, I don't want to leave this as a fraction, because I can make this one, work with just the basic rules of differentiation, and that means I'm going to write x to the negative 1/2. Okay, well now I've got a nice, just non-quotient, so I can use the basic differentiation rules. So f prime of x is equal to, I'm going to take the derivative of each of these terms separately and add them together. So we have, let's see here, we're going to take that power of, well, let me show the work. We are just learning this, right? So we're going to do the 2 times the derivative with respect to x of x to the 1/2 power plus the derivative with respect to x of x to the negative 1/2 power. And I've pulled that constant out of the derivative using the constant rule. So this is going to become 2 times 1/2 x to the negative 1/2. I just, I'm subtracting by 1, right? 1 minus, or 1/2 minus 1 is negative 1/2. Plus, pull this out front, so I could write just minus 1/2 x, bringing that power down. I need to reduce this by 1. Negative 1/2 minus 1 is negative 1 minus 2 over 2, so negative 3/2. And, 2 times 1/2 is just 1, so I'm going to erase that and just write 1. Okay, well, great, but, I still not really happy with negative exponents in my answer. So I want to see if there's a way that I can rewrite this so that I don't have negative exponents. And I'm going to do that with factoring. Now each of these terms have an x in them. So that means that I can pull an x out. But how many can I take out? If you haven't done this yet, or forgot how to from pre-calculus, if I say we have 2x to the 4th plus 3x cubed, how many x's can I factor out of those two terms? I can factor out as many x's as they can all give up. I can factor out 3 of them. I can't factor 4 out because this one doesn't have that many. I look for the lowest exponent, and that's how many I can divide out. This becomes, of course, x to the 3rd times 2x plus 3. So when you factor out a common factor with variables, of course, you are looking for the lowest exponent. Well, between negative 1/2 and negative 3/2, which one is the lowest value? The lowest value is the negative 3/2. So we're going to do x to the negative 3/2, and bear with me here because I'm going to do this verbally. No, I'm not. X to the negative 1/2, what do you do when you factor out? You divide it out. I just want to point out that when you divide like bases, you subtract the exponents. So from each of these, we're going to divide out x to the negative 3/2. Okay, so when you divide like bases, you subtract the exponents. So negative 1/2 minus a negative 3/2 is negative 1/2 plus 3/2. Well, that's equal to 2 over 2, or 1. So we have x to the negative 3/2. This becomes, as I just said, x to the 1st. No need to really write that. Minus 1/2. Well, I have x to the negative 3 halves, or I have x to the negative 3 halves, and that's exactly what I'm dividing out, of course, so that cancels. And we just have x to the x minus 1 half inside. Well, I still have a negative exponent, but now it's just in one spot. It's in one factor, and I can move that base with the negative exponent down to the denominator and create a fraction. This is the shorter of the two. If I'd left this in quotient form, I would be doing more work, by the way. So f prime of x is equal to x minus 1 half over x to the 3 halves power. And, we can call that a day and be happy with that. If you could find common denominators and write this as what? 2x minus 1 over 2x, and but that's good enough. We've already done enough work. That's a good place to stop for our derivative. Again, unfortunately, with these derivatives, you might be happy where you've stopped and then gone to the back of the book and looked at their version of the derivative, and it could appear to be different because they simplified to a different point that you did. So make sure that you continue to simplify to a point where your teacher is happy with what you've got. I just paused and looked at my own notes and thought, that's not what I wrote in my final answer. So let's make this look a little different. What if I don't want a fraction over a fraction? I could find a common denominator and flip the bottom up, but I think it'll be a little bit easier if I make it look this way. If I go ahead here and find a common denominator with these two terms and multiply this on the top and bottom by 2, then I'm going to have x to the negative 3 halves times 2x minus 1 over my common denominator of 2. And now when I go ahead and move that base with the negative exponent to the bottom, I'll have a simpler version of the answer and have 2x minus 1 over 2 times x to the 3 halves power. Now let's go ahead and call it a day with this example and move on to the next. For our next example, we have if I left in this form, it'd be a lot of work to try and find the derivative of this function. So I'm going to go ahead and take this x to the 3rd power and distribute it through the parentheses and get f of x is equal to, well, if I have x to the 3rd and I divide by x, I have x squared minus 2x to the 3rd over x plus 2. Now, at this point, you can find common denominators and put these together, or you can leave it as two separate terms as I'm going to, because we know that when we find the derivative of two functions subtracted together, I can find the derivative of each individual term or function, and then just leave it in that subtraction form, or simplify if I feel like it. So f prime of x, or the derivative of x, that's nice and simple. It's just going to be 2x, and then minus with a set of parentheses. Now, leaving these in two separate terms, I do need to be careful about that minus sign and make sure I distribute it through my parentheses when I'm done. So maybe you might feel it's better to have this as a single fraction before you start the problem. But we're not. So we're going to do the denominator, which is going to be x plus 2. Now I'm going to kind of quicken this up a little bit. Times the derivative of the numerator. And the derivative of 2x to the 3rd is going to be 6x squared. Minus the derivative of the denominator now, because I just took the derivative of the numerator. So the derivative of the denominator is going to be the derivative of x plus 2 is just going to be, well, that's a constant, so it's 0, and the derivative of x with respect to x is simply just going to be 1, times, so that's the derivative of the denominator, times, where am I at, 2x to the 3rd. All of that over the denominator squared, or x plus 2 squared. Do a little bit of cleaning up and we'll be done. So we have 2x minus 6x squared times x is 6x to the 3rd, and 6 times 2 is positive 12x squared, minus 2x to the 3rd, all over x plus 2 squared. let's see, we have, yes, we do have common, or excuse me, like terms with the 2 cubed, or 2 terms of the degree of 3 in there, so we have 2x minus 6 minus 2 is 4, x cubed plus 12, x squared all over x plus 2 squared. We could factor out a 4, I was thinking plus sign. Well, this supposed to be plus sign, I forgot the 1. Plus 12, there we go. Now, we could factor out a 4x squared out of the numerator, but it will not cancel with the denominator. We could find common denominators here and write this as one big fraction if we like, but we're going to go ahead and quit with this and say that is the derivative of f of x. Bam! Last example, coming up. Last example, f of x is equal to 2 minus 1 over x all over x plus 3. That would be a heaping full of mess if you try to find the derivative of that. So we're going to rewrite the equation, function a little bit, make it a little bit cleaner, and then go from there. I want to put those 2 terms in the numerator together, so I need common denominators. I'm going to multiply that by x on the top and bottom there and get 2x minus 1 over my common denominator now of x. And that is all over x plus 3. Now you can multiply the top by x over 1 and the denominator by x over 1 to cancel out that denominator of x, or you can do what I like to do, which is anytime you have a fraction over a fraction, you flip that bottom up and turn that division into the multiplication of the reciprocal. So we're going to take that division again, numerator divided by denominator, or a fraction divided by a fraction, and we're going to change that division to multiplication of the reciprocal and get 2x minus 1 over x. Let's go ahead and distribute that together. X times x is x squared, and x times 3 is 3x. Right? Yes. So now we have f of x is equal to 2x minus 1 over x squared plus 3x. And that is almost exactly what I used in as my first example in this video. So I'm going to walk out, give you just a second to pause the video, work it out for yourself, and then when we come back, I'm going to have the solution already worked out. So that'll shorten up the video and give you a chance to make sure you completely understand how to do these problems, and then we'll be done. Hope you got it. We have f of x is equal to blah, 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 blah. Hope you got it right. I'm Mr. True. Bam! Go do some more homework.